Hello and welcome everyone. So in this video, I'm going to talk about strategic ignorance. And as I mentioned in the moral constraints or some of what economists have to say about morality lecture, I kind of talked about the paper from Rabin and introduced the idea of thinking of morality either as a preference or as a constraint and how this affects the information that people will seek when they're making decisions. This is sort of like part two of that lecture. So, or kind of part two of the lecture series. I mean for these to be kind of complements. I mean for these to go together, right? So the Rabin paper invites us to think of morality as constraints rather than as built-in preferences. And this gives us a theoretical model, can be thought of as an experiment for the DWK and the van der Waals experiment that I'll talk about. There's actually a second van der Waals experiment 2013 paper that I talk about at the very end there. But anyway, so we'll consider these papers. Basically what they are doing is they've got two experimental designs where morally relevant information can be selected or avoided by subjects in a modified dictator game. Why is that relevant? Well, remember from the Rabin paper we were thinking of we could model morality as constraints or as preferences, and presumably people have very different behaviors in terms of relationships with information based around whether that information is going to help them or hurt them relative to their own goals. So for instance, well, if people see morality as a constraint, then they might have an interest in avoiding information that might cause them to act otherwise against their interest. If people see morality as a preference, well, now people might want to find all the available information to be able to seek after whatever is that goal. So in these experiments, what we're interested in doing is we'll say, okay, well, let's have people able to select or avoid information and see what they end up doing. All right, so in the DWK paper, it's called Exploiting Moral Wiggle Room, Experiments Demonstrating Illusory Preference for Fairness. This happened at Pitt. I visited at Pitt for 2 years. So right out of after I left Arizona. So this is it's a really fantastic laboratory. It's an interesting space, and a lot of the Pitt undergraduate social science majors, especially econ majors, will participate in these experiments, and it's really a cool opportunity. We had that at Arizona as well. Anyway, so DWK observed that prior empirical evidence suggests subjects are generous, and this has actually possibly been interpreted as preferences for equitable, efficient, or socially desirable outcomes, but maybe it's just actually people want to appear to be fair. Right, so the idea is like we've got the dictator game, we've got the ultimatum game, we've got a lot of experiments where it seems like people have preferences for pro-social behavior, and DWK are saying, wait a second, not so fast. Maybe it's just that people are trying to appear that they're being fair. It could be an experimenter bias. It could be that they're trying to appear to be fair from the standpoint of those who are conducting the experiment, or it could be for themselves. They want to tell themselves a story that they're a fair or generous person or whatever, and they could be lying to themselves just as easily. And so anyway, so what they're doing in DWK is they want to test whether the observed behavior could arise simply from the desire to appear fair. In fact, maybe the underlying motivation is actually just a self-interest interacted with the goal of trying to continue to appear unselfish. Parentheses, my parentheses, to themselves or to others, right? So they begin with a modified dictator game. They generate high rates of fair behavior. That's how you want to start an experiment, right? So if you want to study something, you want to set up your experiment so you get what you're looking for, and then you try to modify with different treatments. And so they set up a dictator game. They get as their default high rates of things that look like fair behavior, so this now becomes a good context to study. And then they show fairness drops off when subjects lose track of the connection between their choices and outcomes, and then suggests some support for the idea that maybe people are just trying to appear fair. All right, so as in Rabin, right, they're thinking of fairness as a constraint the decision makers might try to get around rather than a goal to implement, right? So fairness, you think of morality as a constraint versus as a preference. Many subjects in the experiment appear to be motivated by self-interest while attempting to maintain the belief that such behavior is not inconsistent with fairness. All right, so here's how the experiment works, right? In the dictator game, DG dictator game, players know the actions and the payoffs chosen, right? And then this is called transparency in this experiment. So the dictator game, like a standard version would be, you've got a dictator, they have $10, they can give anywhere between $0 and $10 to a recipient. The recipient gets the $10, gets the money and has no recourse. That's just how it works. You can give, if you're the dictator, you can give 0, you can give 10. Whatever you don't give, you walk away with on your own. And everybody knows this, and so that's transparency. When the link between the dictator's actions and social outcomes is transparent, then the subjects are fair, at least in this experiment. So by fair, we mean like giving something, like not just keeping all $10 for themselves. In fact, there's more selfishness when the link is obscured, so bad social outcomes do not result from the dictator's choice in a certain and direct fashion. Right? There's more selfishness when it's not a clear, so because think of what's happened. If you're the recipient and you know there's a clear link between what the dictator's done and what you've gotten, then you know that they intended to give you nothing if you walk away with nothing. Okay, so this is why it's sort of relevant. So what they're arguing here is people are fair without really wanting to be just because they don't want it to be discovered that they're not actually a fair person, right? So, all right, here's the baseline. The baseline is the dictator has a binary choice between a fair outcome of 50-50, $5 and $5, and an unfair outcome of $6 and $1, right? So this is already a little bit of a different change from the standard dictator game, because the standard dictator game, you've got $10 and you can give as much or as little of it as you want. Here in this experiment, you can give either 5 and keep 5, or you can give 1 and keep 6, right? Now, to avoid framing issues, which is significant, these are called just option A and option B. And then subjects were paid privately at the end of the experiment. So subjects were paid, but it was not observable. This was 38 undergraduates and 19 pairs at Pitt in sessions of at least 12 conducted via computer terminals. So these are at computers. They've got, it's like cubicles, so you can't see the screens for those sitting next to you. You don't know where your partner could have been. It could have been the person next to you, could have been behind, in front, wherever. So 74% of the dictators chose the fair option, B. All 19 recipients chose the fair option. They were given a hypothetical choice, right? So if you were in the dictator role, 74% said, we'll do option B. If you were in the recipient role and you were given the choice of hypothetically what you do, all of them chose the fair option, right? Option B. So that's interesting. And that's sort of like a side note to something interesting about the experiment, especially in light of the original position and choosing behind a veil of ignorance idea from Rawls that I talk about in the distribution lecture. All right, so the first manipulation was the hidden information treatment. So now the payoffs to the recipient are initially hidden and either align or conflict with the dictator's interests, meaning you don't know what the other person's going to get, and it's either you do well when they do well or you do well when they don't do well, right? So dictators didn't know initially whether A or B would end up giving the recipient the $5 or the $1. Each was equally likely, right? Because like if you knew that, okay, you could either get option, you get 5 or you get 6, either way, and the other person is going to get 1 or they're going to get 5. If you knew that you were getting 6 when they were getting 5, rather than 5-5 or 6-1 or whatever, of course that's what you take, right? You'd rather, I mean, the other person's payoff would still be 5 and you'd increase by 1. So anyway, so they didn't know which option would end up happening, and each was equally likely. All right, so here for this experiment, for this version, the hidden information treatment, there's 64 undergraduates and 32 pairs at Pitt, again in Peel versus via the computer laboratory. In the first manipulation, here's the results. 10 out of 16, 63%, facing the same payoffs as baseline, chose the unfair outcome, meaning when they face the same payoffs as the baseline, they chose the unfair outcome, $6 and $1. 18 out of 32%, 56%, or 18 out of 32, 56% revealed the true state, meaning, remember, it was equally likely what the other person was getting. 56% learned what was going to happen, what was going to be the fate of the recipient. Was it going to be 5 or was it going to be 1? 15 out of 32, 47% revealed the true state and chose the fair allocation. Although not uniformly true, the message from this treatment is, well, overall, dictators tend to be choosing not to reveal the true payoff, even when it was costless to do so, right? It didn't cost them any payoff to learn what was going to happen to the recipient. So we see dictators, therefore, maximizing their own payoffs while remaining strategically ignorant as to the consequences for the other player. Second manipulation was the diffusion of responsibility treatment. 2 dictators and 1 recipient. I think this is absolutely ingenious. So you have 2 dictators, either can implement the fair outcome, neither acting alone can implement the unfair outcome. So if either dictator chooses B, then it's 5-5-5. If both dictators choose A, then it's 6-6-1. Choosing the fair outcome ensures it occurs. Choosing unfairly leaves it up to the other dictator to ensure fairness, right? If either one chooses B, if anyone chooses B, everybody gets 5. But if somebody chooses A, the 2 dictators, if both choose A, not somebody, if both choose A, they both get 6-6-1. So it's kind of like, I'll do it, but then it'll be on the other person to determine what'll end up happening, right? Okay, in the second manipulation, the diffusion of responsibility treatment, again, 2 dictators, 1 recipient, 30 undergrads, 2 sessions, 15 subjects, each via computer terminal. 2/3 were dictators, right? Because there's 2 dictators to every 1 recipient. 35% of subjects chose B. What happens when you choose B? If either chooses B, they get 5-5-5. 35% chose B, which means there's a lot, but 65% that chose A, right? So that's interesting because now you've got a lot of people. That doesn't mean that was the outcome, right? Doesn't mean that. But what ends up happening was, in order to be able to get everybody choosing, in order to be able to get the 6-6-1 payoff, you need both to choose A, but you have a lot choosing B. Okay, so it seems like this is I said a lot. You have a lot not choosing B. You have a lot of people who are choosing the unfair. You have a lot of people who are choosing the unfair outcome, and then when it's not clear, necessarily what's happening. So, okay. The third manipulation, the plausible deniability treatment. Dictators can be randomly cut off by the computer before making a choice, and this one also is brilliant. So the dictator gets a 10-second interval during which to make their choices that be interrupted with a randomly imposed selection if a choice has not yet been made. The receivers don't know if a cutoff occurred, and if their payoff came from the computer randomly or from the dictator on purpose. So this is the moral wiggle room part of the paper, moral wiggle room. So in this plausible deniability treatment, 22 out of 29, or 22 out of 99, 55% of uncut off dictators chose A. 24% of dictators allowed themselves to be cut off, and I think I might have missed. I forget exactly what happened there, but it was 55% of uncut off dictators chose A. 24% of dictators allowed themselves to be cut off with a mean time of 4.3 seconds, with no cutoff occurring before 4 seconds. Right? You have almost a quarter of the dictators just letting themselves be cut off, and the mean cutoff time of 4.3 seconds, no cutoff occurring before 4 seconds. So what's happening as a result is we see, they're observing more selfish choices and finding dictators making intentionally slower choices, which allowed for cutoff. In 10 of 29 choices, 34% were consistent with a desire for fairness, which isn't very high. All right, so that's interesting. Sorry, I hope you can't hear my dog barking in the background. It's super distracting to me, but hopefully not for this video. Anyway, so the van der Waal paper now observes these results and some others and says, okay, this strategic ignorance raises the question of what determines information acquisition and ignorance of socially relevant information. So what is it that's causing people to choose to remain ignorant? So now what they do is, or what this paper does, is they've got a new experiment trying to understand how the choice for ignorance depends on the personal cost for altruism. And so what they ultimately show is, the information management that the dictators engage in is really going to depend on costs and benefits of altruism, and not in the same way. So what they do is they try to generalize the hidden information treatment. This took place in Frankfurt. And their baseline treatment is you've got dictator choosing either A or B, yielding payoffs of 100 or 60 to themselves. Both players are told a computer randomly assigns payoffs to the recipient associated with the dictator's choices. So the dictator's choosing between 100 or 60 for themselves, and then the computer's making the other choice. Now there's two games. So it's not just 100% random. You know kind of what the realm of possibilities for the recipient is because it's governed by these two games. There's the conflicting interest game and there's the aligned interest game. The conflicting interest game gives the recipient 10 when the dictator gets 100 and 60 when the dictator gets 60. So it's conflicting interest because the recipient gets their low payoff when the dictator gets their high payoff. In the aligned interest, the recipient gets 60 when the dictator gets 100 and gets 10 when the dictator gets 60, right? 60 is the low payoff for the dictator. 10 is the low payoff for the recipient. All right, so those are the two games that can result. Now the dictator is going to make two choices. They're going to choose whether to learn which game is actually being played and then whether to select A or B. So here, ignorance is not a default option like in, I said DKW, it should be in DWK. The DWK paper, ignorance was a default option. Here, ignorance must actually be chosen by the dictator because they're forced to choose one or the other. Now, in this Vanderweel paper, there's no cost to remaining ignorant or acquiring information, like no monetary, no payoff cost, but you do have to click through. And so that can have an effect, right? Because now you've got people actually making an active choice. I want to pause for a second. We're going to think about the nudge paper, and we're going to think about nudge from the standpoint of environmental choosing between a green or a gray technology. A green technology that's good for the environment, a gray technology that's not so good for the environment, but that's less costly. And we'll have people choose between, we'll see in the paper, the suggestion of people choosing between these different technologies. And this will be the Sunstein and Reach paper. And anyway, so the interesting thing with some of these setups is thinking carefully about what's the status quo and thinking carefully about requiring people to make a choice. So in the DWK paper, the status quo was ignorance. In this paper, it's a forced choice. You can think about this with like organ donation. There's a couple different ways to set it up. It could be a default that you're not in the organ donation pool. It could be a default that you're in and you can opt out. It could be an opt-in, it could be an opt-out, or it could just be a forced choice. And so actually kind of a lot of interesting research suggests that if you want a high rate of organ donations, what you want to do is you want to force people to be in, and then you make it costly to get out, but possible. I don't know that that's necessarily what you'd want as a side. Who knows? But so if you really want people to, the best thing, if you really want people to make a decision for themselves, is to make a forced choice. You can choose to be in or you can choose to be out, but you have to make the choice. That's actually my preferred mechanism, is just forcing people to make a choice one way or the other, just like they do in this paper. Right. Anyway, so the experiment proceeds with 3 treatment variations. So we have cheap fairness, so equivalent to baseline, but the payoff to the dictator following A is 70 rather than 100. Why does this make it cheap fairness? Well, the baseline payoffs have the dictator getting either 100 or 60. Now if you make the payoffs, the dictator's best payoff 70, so they're choosing between 70 and 60, it doesn't cost them much to go to 60, right? So that's why it's called cheap fairness. So the payoff following A is only 70 rather than 100. Whereas like if the payoff was still 100 and you drop down to 60, now you've given up 40 to get to 60, or to take 60 and to do whatever for the other person. So the dictator is giving up less to implement the equal distribution in the conflicting interest game, right? The equal distribution in the conflicting interest game would be the recipient conflicting interest game. So the payoffs would be 10 versus 70, and then 60 versus 60. So if I have 70 here, it only costs me 10 to get this 60, whereas it's giving the recipient another 50. Okay, so that's kind of what's happening here with this cheap fairness. All right. Then there's the increased loss treatment. So now the payoffs are equivalent to baseline, but the worst possible outcome to the recipient is now minus 20 rather than 10. So I get the 100 when the recipient gets minus 20. I can't remember. I I'm now suspicious about this line that the recipient can lose their show up fee. I can't remember exactly how they paid. Maybe there's like a monetary conversion thing. Typically, the show up fee for an experiment would be about $5 in the US. Typically, European experiments give about €5 for a show up fee. It can be more generous. Sometimes, typically, experiments involve playing for real money, so you build on your show up fee. Typically, you walk away with more than you come with more than more than you given for showing up, so more than $5. The most generous experiment that I helped out with was, I think, at the high end, people were walking out with like $50, which is pretty good for an experiment that lasted 2 hours on campus. But anyway, so I think what happened here is to actually implement a true cost. I think the recipients could lose their show up fee. I think that's how they implemented. There's a couple different ways you can do this so that people are still compensated for their time. One thing you could do is you can have subjects come into the lab. You can have them do something to earn some money, like do some other task, and maybe a quiz or an effort task or something like that, such that you get your $5, you've earned $5, and then it's the $5 you've earned that you could lose. I don't remember. I'll have to look back at this paper. I'm a little bit suspicious about this at this point. Although this would make it, so on the one hand, it would make it real, make it interesting in terms of like the choice for the dictator. On the other hand, from the standpoint of how we like to do experiments in econ, there's kind of like two big things about experiments in economics. One is there's no deception. So psychology is famous for deception. In econ, as a rule, there's no deception in experiments. And the second is we regard this show up fee as sacred. We want to treat our subject pool as really, kind of respectful of the students who are coming in to do the experiment and respectful of their time. And so we care a lot about no deception. We care a lot about respecting the show up fee. And it seems anecdotally, at least, like, and from like what people say around the field, like the discipline does a pretty good job of safeguarding those things, such that like it can be difficult to publish a paper. Probably wouldn't be able to publish a paper if you use deception, unless it was like a really rare circumstance. And the reason why is just because economics doesn't want to generate that same, like, experiments are so crucial. We don't want to have the same sort of bad reputation for experiments as psychology does. So anyway, and then the likely loss treatment was payoffs are the same as baseline. Conflicting interest game is more likely to be randomly selected by the computer. Remember, originally the conflicting interest game was likely to be selected half the time. Now it's 80% of the time. So that's why it's likely loss. It's more likely now, 30% more likely that the recipient's going to get a 10 rather than a 60. Okay. Here's the results. The percent remaining ignorant. In the baseline treatment, 31% chose not to reveal what would happen to the recipient. In the cheap fairness condition, only 6% chose not to remain ignorant. In the increased loss, 17%, likely loss, 29%. I like this cheap fairness one. That's interesting. So when it's not going to cost me very much to give a little bit more to the recipient, then I'd want to know, and that's what, well, I'm talking about myself, but like, I don't mean to be, I'm just taking the perspective of the person in the experiment, I guess, right? So, but here again, just like the whole point of strategic ignorance, the story I want to tell myself is that I'd be really generous to the other player, and I don't. That's what I want to maintain. Maybe I would be exactly one of the subjects that DWK is talking about. So who knows? But in cheap fairness, when it didn't cost very much to be able to help out the other person, the subjects wanted to know. In the other cases where it costed more to help the other person, people didn't want to know. You could think of why, right? If I can make the choice and just choose my 100 and walk away not knowing if the other person got 60 or only got 10, then I don't feel as bad as if I take my 100 and I know for sure they get 10, whereas we could have each walked out with 60, right? So what they do then is they add the ignorance rate to those who knew they played the conflicting interest game and still chose A, right? So in this game, A was the option with 100, right? And then in the cheap fairness, A was where they got 70. Okay, so the percentage in ignorance plus those who became informed but still chose their highest payoff, behaving for all intents and purposes, incompatibility with an interest in equal distribution. So the baseline would be, in the baseline treatment, this is 53%. In the cheap fairness treatment, this is 22%. In the increased loss, this is 47%. Interestingly, not statistically significantly different from what happened in baseline. And then likely loss was 56%. Again, not statistically significantly different from baseline. And so in other words, the results are, well, thinking about baseline versus cheap fairness, there's this increase in cost of pro-social behavior. And it has a sort of double whammy effect where ignorance increases fivefold and there's a double in self-interested behavior in the conflicted interest game. The basic idea is like what's happened is you have a lot of dictators behaving inconsistent with a desire for equal distribution, right? So these are those who are trying to remain ignorant, and these are those who know what's happened and then still choose the unequal distribution. So these are those classified as inconsistent with a desire for equal distribution because, well, if you're cared about the equal distribution, you probably want to know what's going to befall the recipient when you do one thing instead of another. All right. Comparing baseline to the increased loss, well, the ignorance rate decreases relative to the baseline. The rate of choosing A amongst informed dictators shows a slight increase, right? So where there's an increased loss, where this is the one, remember, where the recipient would get a -20, the rate of choosing A amongst informed dictators shows a slight increase, where now you have informed dictators. It seems like it looks like dictators are trying to become informed because they have this taste for information, not necessarily a taste for the equal distribution. All right, so comparing informed to uninformed dictators overall treatments, 49% of informed dictators chose B. So just less than half chose what would be the more equal distribution. All subjects remaining ignorant except for one chose A. So it seems by and large those who were choosing the 100 payoff or the 70 payoff, choosing their highest payoff, did so without regard for wanting to learn about what happened to the recipient. Interestingly, in terms of the payoffs, well, inequality increases with ignorance, whereas the informed dictators earned about 2.6% as much as the recipient. The ignorant dictators earned 10 times as much, 22% on average more than the informed dictator. This last line is just saying there's an economic incentive here, and so these dictators who remained ignorant, right, and the 51% who didn't choose B, you did better when you remained ignorant, at least in terms of monetary payoff. So interestingly, as a result, we see, the price of altruism affects whether people want to learn the consequence of altruistic or pro-social actions. We find that subjects are more motivated to look the other way if the pro-social behavior is costly, which is consistent with a desire to avoid inconvenient facts, which we should expect if we believe that agents are going to view morality as a constraint on the behavior, as suggested as one of the modeling conventions from the Rabin paper. And then we see the size of benefits of altruism for others has no significant effect on the information acquisition. The benefits of altruism to the other people didn't seem to have a really big effect on whether you consumed information about what was going to happen to the recipient. So whether altruism was, so what could happen to the recipient didn't necessarily have a huge impact for whether the dictator learned or not. All right, so the explanation, thinking about reflecting on what they found in the paper, well, it looks like ignorance is serving as an excuse for selfish behavior, either towards oneself or others. There's another paper. So Grossman and Vanderweel argue ignorance is chosen as a compromise between material interest and a desire to maintain a self-image as an altruistic or fair person. And so this is another paper. I actually saw this one presented when I was at Arizona by Grossman. 37% in that survey stated that those who revealed the game type did so out of fairness, and subsequent choices were indeed consistent with this. So when you do one of these experiments, it's nice to then survey subjects and ask them why you did what you did. 37% said, when I looked to determine what happened, like what was going to happen to the dictator, or sort of to the recipient, I did so because I cared about fairness. And then subsequently, the choices indeed followed what they actually did, followed what we would expect to be consistent with somebody motivated by a concern for fairness. 34% who informed themselves, who learned what would happen to the recipient, cited curiosity. In some sense, maybe some preference for information. I suppose that would be like that'd be the most charitable. The most charitable reading would be like they want information. They want to know things. The less charitable version would be like, I want to know if I've done better than the other person, or I want to benefit from seeing that they've not done so well, or whatever is the case. Like, you could tell a lot of stories here. So the most charitable story is like, these individuals who are just curious actually just wanted the information, wanted to know what would happen. I don't know. On the other hand, in an experiment like this, we're talking about the difference between like, let's say $10, 10 experimental dollars, something like that. And so it's not it'd be interesting to see how an experiment like this would work if it was with like thousands of dollars, right? So if I'm in an experiment as a subject, and actually, so it's interesting because dictator games and ultimatum games seem to be, those findings are pretty robust across different economies where, $100 is a lot more than it is in the U.S., or $10 even. So it'd be interesting to do this experiment in one of those areas. But my thought is just, I don't know. I would think maybe if we're looking at subjects at Pitt, or looking at subjects at Frankfurt, maybe if we're talking on small scale, where the payoffs are in the order of like, $10 or $20 or 10 or 20 euros or whatever, we might expect people could let themselves off pretty easy, and could maybe not be too bothered about depriving another player of like $10. Whereas like, if it was the difference between thousands of dollars, now all of a sudden, or hundreds of dollars, now there might be more of a, maybe the underlying fairness, I don't know. I would hope the fairness considerations would be a little bit more salient in those circumstances. But that's just my sort of speculation on what would be an interesting extension of this work. Would be thinking about, this would be one in particular where I'd like to see how people behave with much larger scale payoffs. Anyway, so hope you enjoyed the video, and I'll go ahead and conclude here.